these 7 notes look a little bit different. I found this online and then I just tweaked it to fit me, but I like the little characterization stuff. Basically, this is section 4.5. Right. So we are still in chapter 4. This section is all about graphing rational functions, and there are quite a few steps to go through to graph rational functions. And so this just gives you an example of a word problem that involves concentration of a drug in the bloodstream over time. This is a rational equation, and so to graph this would help us to be able to figure out as to what time, at this time, how much the drug will be in the bloodstream. Right. So rational functions are functions that are fractions, and there's like a polynomial in the numerator and the denominator. And so remember, since we have variables in our denominators, and most of these, the denominator cannot equal 0. So, and they just tell you that it's a rational expression because it's a ratio. All right, now, the domain is found by finding excluded values. These are values that would make the denominator 0. So we've talked about this before. We know we cannot have 0 in our denominator. So to find the excluded values, you set the denominator equal to 0. So this is the first thing, one of the first steps we'll be looking at. You're going to set the denominator equal to 0, and then solve to find the excluded values. And then 99% of the time, these are going to become also our vertical asymptotes. So if I look here, this doesn't have a variable in our denominator, so it really it's not an issue. So this one we're good to go. So this would be this domain would be all real numbers. Here, if we set x squared plus 4 equal to 0 and solve this, we have x squared equals negative 4 at the square root. So this gives us x equals the square root of negative 4 is going to be plus or minus 2i. Now, like I said, we're going to be graphing in this section, and so we are not concerned with imaginary solutions. And so, because this is imaginary, it does not concern us. And so here again, we would say that this domain, we don't have any excluded values in the real number system, so it would be all real numbers. And then this one, if we set this equal to 0, we realize that x cannot equal negative 2. Or we could write this like negative infinity to negative 2 with parentheses, union, negative 2 to infinity. So it can be any number, but not the number negative 2. All right. Now, here, they are asking us to find the domain and the vertical asymptotes of these three. And so, if you're in class, I would just say, you go ahead and work these out, but I will work on this video. All right, so this domain, we would say that we set the denominator equal to 0, and so we get that x cannot equal positive 3. Or you could write it negative infinity to 3 union 3 to infinity. Now, to find the vertical asymptote, it's going to be this same thing, but we would write it for the vertical asymptote. Since remember, asymptotes are imaginary lines that the graphs approach, and so we're looking at a vertical line, so the equation is going to be x equals. And so even though the domain is x cannot be 3, because the graph is undefined there, that becomes an asymptote. So we would say x equals 3 would be the vertical asymptote. Okay. Here, right now, this denominator, when we set equal to 0, realize we can, to solve it, we can factor it, or use one of your other methods you have for solving quadratics. So I'm going to have x squared plus x minus 2 equals 0. So x and x, and to get negative 2 with a positive 1, it would be a positive 2 and negative 1. So I set each of these equal to 0, and I get x equals negative 2, x equals 1. So this domain is x cannot equal negative 2 or positive 1, or you could write it in interval notation like negative infinity to negative 2, union negative 2 to 1, union 1 to infinity. And then the vertical asymptotes are going to be just this. X equals negative 2 and x equals 1. Okay. And then over here for the last one, set this denominator equal to 0. Divided by 2, x equals negative 3. So for the domain, that means x cannot be negative 3, and then the vertical asymptote would be x equals negative 3. Okay. All right, next one. Then we talk about horizontal asymptotes. Now, there are 3 different scenarios that we can have, and that's why it's laid out this way. So to find horizontal asymptotes, we're looking at the degree of the numerator and the denominator. So if the degree of the denominator is larger, then the horizontal asymptote is just going to be the x-axis, which is the equation y equals 0. So horizontal lines are y equals, right? If the degree of the numerator and denominator are the same, then the asymptote is the ratio of the leading coefficients. So you would think that the polynomial would be in order, descending order by powers of x. And so you take the leading coefficient of the numerator and the leading coefficient of the denominator, and that makes a fraction or a ratio. And that is the equation, y equals that value, is the equation of the horizontal asymptote. That's when the degrees are the same. Now, if the degree of the numerator is larger, it's not horizontal at all. We have what is called an oblique asymptote, or most people would say slant asymptotes. Your textbook will say oblique. So it's most of the time it's just like a slanted line, and it's here again, imaginary line that the graph approaches. And so this is when the numerator is larger. So to find this asymptote, you're going to have to divide the denominator into the numerator. And so you can do, most of the time you can do synthetic division. There are times where you may have to do long division to do that. And it says here, there can only be one horizontal or one slant asymptote, but never both. But see, while ago on the vertical, we had more than one. But when we're talking about horizontal or slants, it's just going to be at most one. And it won't be both. It'll be one or the other. Okay? And now we're looking at these 3, and we're going to find the horizontal asymptotes. So we look at the degree. This is just a single constant on the top. So this is x to the first. So for A, since the degree of the denominator is larger, then the horizontal asymptote is going to be y equals 0, because the denominator degree is larger. Okay. This one, they have the same degree, 2 and 2. So in this case, the horizontal asymptote is going to be y equals, so because the degrees are the same, I'm just going to write down here, same degree. And you take the ratio of the leading coefficients. So this is a 1 here in front of this. So it is 2 over 1, which is really just 2. So this is y equals 2. And so this one, I'll just go back and write denominator larger. And we're talking about the degree. So in C, we see that the numerator is larger. And so we have an oblique or a slant asymptote. And so to find it, we're going to have to divide the denominator into the numerator. And so I would do synthetic division. So here, I would have 2, the opposite sign here, and in my backward cell, then I would write 2, -3, -1. Bring the first number down, multiply, add down, multiply, add down. Now, I do not care anything about the remainder. You can just disregard that, okay? And so all I need to know is what is this polynomial going to be for the quotient, all right? Just ignoring the remainder. And so this was x squared, so this would be x, which means that I would have the equation y equals 2x plus 1. And so I'll go back up here and write that. So because it is a slant, I'm going to write SL for slant, and so, or SA for slant asymptote, however you want to do it. And so this is going to be the equation y equals 2x plus 1. Okay. So when the numerator is larger, you have a slant or an oblique asymptote, and you need to divide, ignore your remainder, and then write your equation of the quotient. Okay. Now, important note here. The graph of a rational function never crosses a vertical asymptote. So if you have a vertical asymptote, it's never going to cross it. But the graph might cross a horizontal asymptote, but it doesn't have to. But if it does cross it, don't panic and freak out thinking you're doing something wrong. There's a chance we're going to have problems in our examples and homework that it's going to cross. So it might cross it, but it doesn't have to. Okay. All right, now we can have things in these rational functions that are called wholes, and this occurs. A whole is an x value that does not exist, and this occurs whenever the numerator and denominator have a common factor. Okay, when they have a common factor, we have a whole. And so we're going to find the common factor in the numerator and denominator, and then you're going to set the factor equal to 0 and solve. Then, so people can usually remember this part. Set the common factor equal to 0 and solve. But if they forget this part, then you have to plug the answer into the function after the common factor has been canceled. And this gives you the ordered pair. The whole is a point on a graph, right? And it would be a point where the graph would be undefined there. Okay? So, just to show you a picture, I think I got to erase this because it'll probably show when I slide this out. But this is a graph of a horizontal function, and it has a hole right here. So see, it's not only we have these asymptotes here, but then there was a common factor, and when we canceled out that common factor, it still left us a rational function, but it gave us a hole right here in this spot. Right? So that's what a hole will look like more. Okay. So this one says find the whole, exclude values, and vertical asymptotes. So the first thing we have to do is come over here and factor the numerator and denominator. Okay. So this will factor into x plus 2, x plus 1, and this factors into x and x to get 10, and then a -3 in the center. It would be -5 and a +2. Now you look at your numerator and your denominator and see if you have a common factor. I do, right here. Okay, so this will cancel this. All right, so that's my common factor. So common factor is x plus 2. Right? And so we're supposed to set this equal to 0. So we set this equal to 0 and solve. That gives me x equals -2. So this tells me I'm going to have a whole because I have a common factor. And it's going to be at the ordered pair -2 something, because a whole is a point on a graph where it is undefined, right? So it's -2 something. To figure out what the y value is, you take -2 and you plug it into the reduced fraction. So my reduced fraction is x plus 1 over x minus 5. And so I'm going to plug into -2. Okay, so this is going to give me -2 plus 1 over -2 minus 5 that's just 1/7. And that would be my whole. So that would be the y value. So the whole occurs at -2, 1/7. So at that point on the graph, I would have an open circle for a whole. Okay. So now it talks about, so we found the whole, and now it's the excluded values. All right, so this is where the domain comes in. All right, excluded values, you still use the entire denominator of the original problem. So I pretend like this x plus 2 is still here. So the excluded values would be x cannot equal +5 or -2, right? So that's the excluded values. And then, so that is our domain, right? Now, we talk about finding the vertical asymptotes. So the vertical asymptotes use the reduced fraction, right? So the reduced fraction is, or our new function is f of x equals x plus 1 over x minus 5. So this is where I'm going to get my vertical asymptote. So the vertical asymptote is x equals 5, not the -2, because that was a whole, right? So this would be the only vertical asymptote we would see, right? So if it has a common factor, that means it has a whole, and that's going to be just a few problems, not many, but we'll have some to practice. And then find your domain, which includes everything, all the original problem, and then the vertical asymptotes comes from the reduced fraction. Okay. Really, everything else comes from the reduced fraction. All right, so now, this problem is different from the ones we've had before because we had this number that's being added off to the side. Now, this 2 could be at the front or the back. It didn't have anything to do with it, all right? So I'm going to look at this part of the function, right? So my vertical asymptote, I would take this and I would set this equal to 0. So I would have x squared plus 2 equals 0. This is going to be x squared equals -2 when I take the square root. It's going to be imaginary. So this is none. So vertical asymptote, I have none. Right? Now, horizontal asymptote, this, if I'm looking at just this part, I ignore this constant that's being added to it. This degree in the bottom is larger than the numerator. So this is horizontal asymptote is y equals 0. But remember way back in chapter 2 when we did all the graphing and the shifting and all that stuff, the 2, the k value at the end, shifted the graph up or down. That's what this is doing. So it takes this horizontal asymptote and it's going to slide it up too. So really, whatever you get for a horizontal, if you have a number being added or subtracted, to the whole rest of the function, whether it's in the front or the back, then you just add or subtract that value, and then you end up with y equals 2. So this is the horizontal. Okay. All right, now intercepts. To find the x-intercepts, this is when the graph is equal to 0. So what you're going to do is you're going to set the numerator equal to 0 and solve it. To find the y-intercepts, this is when x equals 0. This is like y equals 0, and this is x equals 0. How do you find this? You plug in 0 for all your x's, and then you simplify what you have. Okay? So, in this problem, they want us to find the x and the y-intercept. So, x-intercepts set numerator equal to 0. Okay? Now, I should check to see if this is going to have a common factor, but it's not. This will factor into x plus 2 and x minus 1. We've done that once already, and so it doesn't have anything in common. So I'm only concerned with right now with x and y intercepts. So I set this numerator equal to 0. That's going to give me x equals 3. So the x-intercept is 3, 0. Right? Now I'm going to find the y-intercept. here, I plug in 0. So this is going to give me 0 minus 3 over 0 squared plus 0 minus 2. This equals negative 3 over negative 2, which is just 3 halves. So the y-intercept is 0, comma, 3 halves, or 1.5. Okay? All right, now these are all the steps that you go through to graph one of these rational functions. So you start off by seeing if you can factor the numerator or denominator, because we need to check to see if there's a common factor, which would leave us a whole. All right, then it says find the real zeros of the denominator. Basically, you're going to set the denominator equal to 0 and solve. And so this is going to give you your domain and your vertical asymptotes. Then you're going to find the horizontal or oblique or slant asymptotes by looking at the degrees. Then you find the x-intercepts. Then you find the y-intercepts. And then, after we find all that, we still might need a few more little points that we need to plot just so we can get the general shape of the graph. Okay? So it's a lot of steps to go through, but as you go through the process, you realize you'll get the hang of it and remember it. But remember, this test is only over 2 sections, section 5 and section 6. Okay? So I have one that is worked out for you. Here's the function. So we started off by factoring, and when we factored this denominator, we realized we don't have any common factors, so there's no holes. And so now you find the zeros by setting this equal to 0, and that gives us the excluded values. And so we end up with negative 1/2 and positive 3. And so the domain cannot equal those, right? And so then that also means the vertical asymptotes are x equals 3 and x equals negative 1/2. Then it says you compare the degrees of the numerator and denominator to find the slant. Because the degree of the denominator is larger, the horizontal asymptote is y equals 0. Here, to find the x-intercepts, you set the numerator equal to 0 and solve, so we end up with negative 3 comma 0. To find the y-intercepts, you plug in 0 for all the x's, we get negative 1. And then we plot a few more points, and we sketch our vertical asymptotes, we sketch the horizontal asymptote, we plot all this information that we found, and then some extra points just to be able to draw more accurate curves. Okay. All right, so here we go. This one is already factored for us, which is nice. And so we can see right away that we have a common factor. So this tells us that we're going to have a hole. All right, and so the hole, we're going to set the common factor. So I'm going to come down here. So I'll go ahead and write the domain. All right, so if I set x equal to 0, x minus 2 to 0, and x plus 1 equals 0, I would get x cannot equal 0 to negative 1. Okay, so I have 3 excluded values, these right here. That cannot be in my domain. Now the whole, I'm going to set, when I set x minus 2 equals 0, I get 2. So I know that my whole is going to be 2. All right. My reduced fraction is going to be x plus 3 over x times x plus 1. Okay. So now I take 2 and I plug it in for x to see what I get. Then I'm going to have 2 plus 3 over 2 times 2 plus 1. So this is 5 over, this is 3, 2 times 3 is 6. So the whole is 2 comma 5, 6. Right? And vertical asymptote. For the vertical asymptote, I use this, so I'm going to cancel this. And so now this is going to equal x plus 3 over x times x plus 1. Alright? So to find the vertical asymptotes, this is what I use. Really, I use this for everything else. I've already found my domain and my holes. Everything else comes from the reduced fraction. So the vertical asymptotes are going to be x equals 0 and x equals negative 1. The horizontal this would be x squared, and this is just x, so the degree of the denominator is larger, so this is y equals 0. X-intercept, you set the numerator equal to 0, so I would have x equals 0, so x equals -3. So the x-intercept is -3, 0. The y-intercept, you plug in 0 for all the x's. So I write this down here. All right, so this is going to be 0 plus 3 over 0 times 0 plus 1. Now, this is 3, but here this is 0 times 1, which is 0. And I cannot have that, so there is no y-intercept. Okay. Now, this just asked us to find all this stuff, and so we did. So we're done with that one. Now, we didn't graph it, but we found all the information. So the rest of them we'll graph. Okay. Right here we go. Same thing again, finding all this stuff. Now, I don't know why this domain is happening. I thought I had moved all these, but really the domain should be one of the first things that you find. So I'm going to put it up here. Okay. So this denominator does factor, but the numerator is just going to be x. So this is x minus 3 times x plus 3. So poles, there are none. Factor. Now the domain, set the denominator equal to 0. That gives me x cannot equal 3 or -3. So the vertical asymptotes would be x equals 3 and -3. Right? So I'm going to go ahead and draw those. I'm going to sketch this in here. I'm going to have an imaginary, so I'm going to make it dashed, vertical line, going up through -3 and +3. Right? Now horizontal. Because the degree of the denominator is larger, the horizontal asymptote is y equals 0. So whenever the bottom is bigger, it's y equals 0. This means we have an asymptote right across here at 0. So I know it's on the x-axis, but I want you to really make it dark, little dashes, or make it stand out past it so I can tell that you knew this was an asymptote. Okay? Now, x-intercept. Set the numerator to 0. So we would have x equals 0. Oh, and so this is just 0, 0. And so the y-intercept, when you plug in 0, you're going to have 0 over whatever, -9. And so that's going to give us 0. 0 divided by anything is 0. So this is 0, 0, which is, I mean, this is the origin. So that's okay. So now, I'm going to put this point here, right? And don't panic, because it said it's never going to cross a vertical asymptote, but the graph might cross a horizontal. So apparently it's going to. So this is our x and y intercept. Now we need a few more points. We don't have enough information. We're going to have curves here and here. We've got to figure out where they are. So this is when you get your graph and you type it in very carefully. I'm going to go to y equals, and I'm going to type in x, and then divided by, and you have to have the denominator in parentheses. If there was more stuff in the numerator, it had to be the numerator in parentheses divided by the denominator in parentheses. And so this is going to be parentheses x squared minus 9. Then I hit graph. It's the screen. Okay, I'm going to hit zoom 6 to get back to the regular screen. Zoom is slow. Right. All right. Now, if you have an 83 calculator, you may see lines like a zigzag going up through here, but it shouldn't be. Okay. So I'm going to now go to my XY chart. I need some points over here on the far left, some points in the middle, and some points on the right to know where to draw these curves. Okay. So I'm going to do the second graph for my XY chart. Now, you don't have to do this the way I do it, but to me, these vertical asymptotes divide the graph into 3 sections. And I know I'm going to have curves here. I got to figure out where it's going to, the curves are going to be. So I'm going to make 3 XY charts. Now, like I said, you can make one long one. It doesn't matter. But I'm going to do XY. All right, I just need a couple of points on this side. So I need some numbers that are to the left of -3. So I'm going to pick x equals -4 and -5. And then I can look this up in my calculator, and this gives me for -4, -0.57, and for -5, -0.31. So I graph this. Let's see, so -4, -0.57, right here. And then -5 and -0.3. So this tells me this curve is going to start hugging this horizontal, and then it's going to come down here and hug this vertical. Right here in the middle, I need some numbers between -3 and +3. So I chose -2 and +2. So -2 is 0.4 and +2 is -0.4. So I have -2.4 and then +2, -0.4. So this is doing this. Right. And then over here on the far side, I just use 4 and 5 because I got to go beyond 3. And so I got 0.57 for 4 and 0.31 for 5. So this is doing this. And they're not always as symmetrical as this one is. This one is pretty good. But that would be the graph, right? Now, don't get hung up so much about the graphing, because usually by the end, this is where people mess up. They can find all the information, but the graphing, they have a hard time. Don't stress out about the graphing, because on the test, it's going to be matching. I mean, like, because it's multiple choice. I want you to be able to graph. I think you should be able to graph by following all these steps. But don't freak out about the graphing, okay? Here's another one. All right, let's factor the numerator. Right, this is x. This will be, all right, this is not going to factor. This is a 1 because the only thing I'd have would be 3 and 1, so that would give me 2. So this does not factor. I don't have a common factor, that tells us that. All right, so no holes. All right, the domain, set the denominator equal to 0, so x cannot equal +2. So the vertical asymptote is x equals 2. All right, horizontal. Okay, this numerator is larger than the denominator, so it doesn't have a horizontal. This has a slant. Or you can write SA, whichever, but it's an oblique asymptote. Okay, so we're going to have to do synthetic division. So I'll do it over here. Let's see if I can put it in. This would be 2, and then I have 1, -1, -3. 2, 1. That's not the same. Okay, now remember, I don't care anything about the remainder. So this is 1 and 1. These are my coefficients. This was x squared. So this would be y equals 1x plus 1. So the slant asymptote is y equals x plus 1. Now, I have a vertical vertical asymptote and a slant asymptote. I'm going to go ahead and draw these. So the vertical, that is at positive 2, so it's going up here. Now the slant. The reason it's called slant is because it is a line, and it is like y equals mx plus b, slope-intercept form. So I'm going to start at at positive 1 on the y-axis, and my slope is 1. So from here I go up 1, over 1, up 1, over 1, over 1. And so this is it. Just make it dashed going down here. Okay? So slanted. Now, the x-intercept, you set the numerator equal to 0 and solve. And so this, I can't even see this problem. I don't see this. Probably moving on my notes. So that tells me probably I'm working this and y'all don't even have it in your notes. All right, I'm going to go ahead and finish it since I've already got a slant down here, and it will be good practice for us to have a slant. All right, this did not factor, so it's going to be quadratic formula. That's what I'm going to have to do. So let me see if I can get some space here. All right, x squared minus x minus 3. All right, so I'm going to have negative b, so that's positive 1, plus or minus the square root of b squared, which is 1 minus 4 times 1 times negative 3, all over 2 times 1. So this is 1 plus or minus to be 12, so it's 13 square root of 13 over 2. All right, let me see what this is. Well, go ahead and change it. Get here. So if I do 1 plus square root of 13, enter, divided by 2, enter. All right, this gives me 2.3 rounded. And then if I do 1 minus square root of 13, enter, divided by 2, enter, I get negative 1.3. Okay. X-intercepts are about 2.3, 0, and 1.3, negative. I think the one's negative. Right. And then the y-intercept, if you plug in 0 for all these x's, you're going to get negative 3 over negative 2, which is a positive 3 halves. So the y-intercept is 0, 3 over 2, which is 1.5. So I'm going to graph these points. So negative 2.3 and a negative. Positive 2.3, sorry, and negative 1.3. And then 0 and 1.5. That's right here. All right, so these points are probably enough for me to draw this. I can tell that this is going to be coming up here. I know it's going to have big asymptotes. Okay. And then I have this point here, but really that's not hardly enough to let me know more about how to draw this. So I'm going to pick some more points. So I'm going to go to y equals and type this in. All right, so this problem was x squared minus x minus 3. I use parentheses, x squared minus x minus 3, and then it's divided by x minus 2. I put that in parentheses, x minus 2, graph. Right? So then I can see my curve. So I had this one. I just need to get the one on the right. So I'm going to go to my table. And this is my vertical asymptote with a 2. So I want to pick some numbers on the right side of 2. So like 3, so 3, 3, and 4, 4.5. So 3, 3, and 4 was 4.5. Okay. 3, 3, and 4 is 4.5. So it's hugging this right here. Okay. So there's the graph. Right. And then this one I have on here. Okay. All right, let's back to this. This numerator will factor. The factors in the 12. Take a 12 out because they have 12 in common at least. Down here, I have an x in common. If I put that out, yep. I have a common factor, so I have a whole. Right, the main first. Set these equal to 0. That tells me x cannot equal 0, and x cannot equal -2. Now my wholes. The common factor is the x plus 2, so I know I'm going to have a whole at -2 something. Right, so now I'm going to cross this out. And so my reduced fraction is just 12 over 6. So when I plug in -2, 12 divided by -2 is -6. So the whole is going to be a -2, -6. Now, vertical asymptote is going to be x equals 0 because that's all I have left in my reduced fraction. Horizontal, the denominator degree is larger, so it's going to be y equals 0. The x-intercept, when I said the numerator equal to 0, I have 12 equals 0. It doesn't make any sense, so there's none. And then y-intercept, plug in 0, but that will give me 12 over 0, so you can't drop a 0, so this is none. Okay. Now, graph this stuff. So I have a vertical asymptote coming through at y. My horizontal is y equals 0. So that takes care of the x and y axes. That's why I don't have a vertical or horizontal. I mean, x-intercept or y-intercept. Okay. Now, I have a whole at -2, -6. I'm going to circle here. Open circle. Right? Now, I really have nothing else to go on, so I've got to XY chart to see to get some other points. So I'm going to go to y equals, and I'm going to 10. So this is really all I have left was 12 over x. Now you can type in the original. Really, 12 over x is what you're looking for. So I'm just going to do 12 divided by x. But if you wanted to type in the original, you could just be sure you see. You had graph. And now I go to second graph to get my XY chart. Since my asymptote is a 0, I'm going to pick some numbers on the left and numbers on the right side of 0. So let's do -1. I don't have to do -2, and I can do -3. Then over here, I'll pick 1, 2. Go back here. So -1 is -12, and -3 is -4, and +1 is 12, +2 is 6, and +3 is 4. So I'll graph these points. -1, -12 runs off my graph, so it's so far down here I can't show that, but -3, -4 I can. That's here. So this curve is going down. So if it's not as close, it will get close to these asymptotes as it goes further out, but right here is not that close. And then this is 112, which runs off, and then I have 2, 6, and 3, 4. So doing the same thing. It probably wouldn't hurt to pick another number like 5 or 6 to see what that is to make it look more accurate. But that's it. And now we'll do this one, and really it's just the same thing over and over. It just takes practice. So we'll do this one. Right, this factors the numerator into x plus 1 minus 1, and the denominator factors into x minus 3, x plus 1. So we have another whole. So the common factor is x. Let me go ahead and x cannot equal 3 or negative 1. I just said the denominator equals 0. So now I'm going to cross out the negative 1. So for my whole, it's going to be negative 1 something. So this reduced fraction is x minus 1 over x minus 3. Now, if I take negative 1 and plug it in, I'm going to have negative 1 minus 1 over negative 1 minus 3. This is negative 2 over negative 4, which is a positive 1. Right, so that's the whole. The vertical asymptote is just x equals 3. Horizontal, all right. These have the same degree, right? Or to the first power. So it's the ratio of the leading coefficients. So this is 1 over 1. So this horizontal asymptote is y equals x-intercept, set the numerator equal to 0. So x minus 1 equals 0, x equals 1. So this is 1 common. Y-intercept, set the denominator, plug in 0 for all the x's. So this is going to be 0 over 0 minus 3. So this is 1/3. So the y-intercept is 0, 1/3. Okay. Now let's draw this one. All right, I have a vertical asymptote of 3. I have a horizontal at 1. I have an x-intercept at 1, 0. And a y-intercept at 0, 1/3. That's enough to tell me that this curve is coming down to 7. I need some points over here on this side to be able to draw these curves, so I'm going to pick some numbers over here. So I'm just going to choose 4 and 5. So I go to y equals and y this. So I'm going to use parentheses. I'm going to have x minus 1 parentheses divided by parentheses x minus 3 graph. Right, and so now second graph is my XY chart, and now 4 is 3 and 5 is 2. So this is 3, this is 2. So I graph 4 and 5, 2 is here. And this last one is the same. If you want to practice it on your own, let's see. It does have a whole this numerator factor. I'm just going to write the answers down, and I'm going to let you factor and then see if you can find them all. So I just go ahead and tell you this whole is 2 and 5/12 domain x cannot equal from is y equals 1/3. And then the x-intercept is -3, 0. Y-intercept is 0, 1.5. So that's all the information.